Welcome back to Tomorrow Unveiled. This is our Thursday segment, Green Code Hot Core, where we really dig into the latest in clean energy and sustainability.
And our research team has definitely been busy this week. They've pulled together some fascinating updates from, what was it, June 5th to the 12th?
That's right, covering quite a mix: tech breakthroughs, some really big investments, and, well, some pretty complex policy shifts happening globally.
Yeah, lots to unpack. We've tried to focus on the developments that popped up across multiple sources, just to bring you the most critical insights.
Okay, let's jump in. What really seems to be jumping out this week, according to the research, is this resurgence, maybe, in advanced nuclear power.
Absolutely. It's striking. There's a significant kind of multi-pronged push happening. We often talk about nuclear for, decarbonization.
Right, the climate angle.
But the sources this week make it really clear that energy security concerns are now a massive driver, maybe even the dominant one, particularly if you look at Europe.
That mix of climate goals and energy independence. Yeah, that's a powerful motivator. So, under that nuclear umbrella, we saw some genuinely exciting stuff: fusion energy first.
Yeah, definitely momentum there. You can almost feel this growing investor optimism.
Like the German startup, Proxima Fusion.
Exactly. They just closed a record private investment round 130 million.
Mm-hmm.
That's a huge vote of confidence from the private sector for fusion.
130 million.
Yeah.
And specifically for their stellarator approach. Remind us quickly what's special about stellarators.
Stellarators are basically these incredibly complex, twisted magnetic cage designs. The idea is to confine that super hot plasma you need for fusion,
Right.
but aiming for continuous operation, unlike some other designs. And Proxima's goal with this funding is pretty ambitious.
Good shit.
They're targeting site selection for a demonstrator plant in Europe, like very soon,
Right.
and aiming to get it operating within the next decade.
Wow, okay, so this investment isn't just for R&D, it's for actually building something.
Right. It really signals a belief that the core physics is moving towards being more of an engineering and industrial challenge now. Solvable problems.
And speaking of stellarators, wasn't there also news from Germany's own big experiment, Wendelstein 7X?
Yes, exactly. They hit a new fusion performance record this week, too. Another step towards keeping that hot plasma stable for longer periods.
So fusion is still, a longer-term prospect for powering the grid.
Oh, for sure. Widespread commercial power is still a ways off.
So these steps, the performance records, the big private investments, they keep that dream of near limitless clean energy very much alive, right?
Definitely. Concrete progress. Now, shifting gears quite a bit, the sources also really highlighted China's leap in advanced nuclear, specifically thorium reactors.
Ah, yes, they're reported to be years ahead in this area.
Which, raises interesting points about where innovation is happening globally. China's actually operating a small 2-megawatt thermal thorium molten salt reactor prototype out in the Gobi Desert.
Molten salt. Okay. And the big news this week.
They achieved a global first with it. They successfully refueled the reactor without shutting it down.
Refueling online. Wow. That sounds like a massive operational plus compared to traditional reactors needing shutdown periods.
It's a huge efficiency gain,
Man.
potentially. It leverages the fact that the fuel is liquid. This molten salt mixture allows for continuous processing, adding new fuel, removing byproducts.
And this tech, it originated in the U.S.
Yeah, the foundational research was done at Oak Ridge National Lab back in the 50s and 60s, but it was largely abandoned in the West. China picked up that research and, well, they're running with it.
So why thorium? What are the advantages the sources mention?
Several potential points. First, thorium itself is way more abundant than uranium, maybe 3 times as much globally.
Okay, abundance. What else?
Proliferation risk is seen as lower. Thorium isn't fissile itself, you see. It has to absorb a neutron in the reactor to become fissile uranium-233. That makes it harder to divert for weapons.
I see. And the waste.
That's a big one. Thorium fuel cycles can potentially produce significantly less long-lived radioactive waste. And the waste they do produce might decay to safe levels much faster than traditional uranium waste. Hundreds of years versus hundreds of thousands.
Those are pretty compelling arguments if they can scale it up successfully.
Right. And China seems serious about that. The reports mention plans for larger 10-megawatt units based on this prototype, potentially deployed by 2029.
Okay, meanwhile, back in Europe, the UK is making a big push for small modular reactors, SMRs.
Yeah, a very concrete commitment there. They've officially selected Rolls-Royce to lead the development and build-out of the UK's first SMRs.
And it's not just talk, there's serious money attached, right?
Absolutely. A 2.5 billion program pledge overall. That includes $210 million directly from the government, plus another $280 million from the Rolls-Royce consortium just for the first 3 units.
3 units totaling about 1.5 gigawatts. That's a significant chunk of power.
It really is. And the timeline they've set is, well, it's ambitious. Site selection by the end of 2025, first grid connection targeting the mid-2030s.
What are the main selling points for SMRs again?
The potential advantages are things like faster construction, because key components can be factory-built and assembled on site, and their smaller scale might allow them to fit into more locations on the grid, maybe replacing old coal plants, that kind of thing.
Makes sense. But the sources mentioned potential challenges too. It's not all smooth sailing.
No, definitely complexities. Waste management came up. If you have potentially more smaller sites spread out compared to a few large plants.
Right, the logistics and security might look different.
Exactly. Planning for waste transport, storage, and ensuring security across multiple locations needs really careful thought to maintain public confidence. It could increase the overall security burden.
That's a really important point considering the whole system, not just the reactor itself. And SMRs aren't just a UK thing, right? There's global interest.
Oh, yeah. Growing interest worldwide. China and Russia actually already have some SMRs operational, though different designs.
So taken together, the fusion progress, China's thorium work, the UK's SMR push, it really paints a picture of a diversified, strategic return to nuclear, wouldn't you say?
Definitely. Driven by that potent mix of climate targets and increasingly that energy security angle we started with.
Okay, let's pivot. Moving from atoms to photons and electrons. Solar and batteries. The pace of innovation here just feels relentless.
It truly is. On the solar side, the big push is still getting efficiency beyond what silicon alone can do. That means perovskite silicon tandem cells, layering materials.
And we saw new panel efficiency records reported just this week, right, from Chinese manufacturers.
Yep. GCL hit 29.51%, and Trina Solar announced 30.6%. Those numbers just keep ticking upwards.
It's important to stress, though, this is panel efficiency, not the super high cell efficiency records we sometimes hear about from labs.
Exactly. Good point. Panel efficiency is for the whole module, the thing you actually install. It's always lower than the record for a tiny, perfect lab cell like LONGG's 34.85% certified by NREL earlier. Getting high efficiency across a whole panel with all the connections and protective layers stable over time, that's the real engineering challenge.
So the race is to translate those amazing lab results into cost-effective, durable panels people can actually buy and install.
Precisely. And the intense competition, especially among the big manufacturers, is definitely speeding that up.
All right, now on to batteries. The landscape here seems incredibly diverse. Innovation isn't just about one thing, it's pushing on multiple fronts for different uses.
Yeah, it's fascinating. What really jumped out this week was an announcement from MIT about a sodium-air fuel cell concept.
Sodium air, not lithium-ion.
Yeah.
And targeted at heavy transport, even short-haul aviation.
Potentially, yes. That's the revolutionary part. It's different from lithium-ion. The key is the potential for incredibly high energy density. The lab tests suggest maybe 1,000 to 1,500 watt-hours per kilogram.
Whoa, okay. Put that in context for us.
Well, current lithium-ion and EVs might be, 250, 300 Wh/kg? So this is potentially 3, 4, maybe even 5 times denser. And for aviation, weight is absolutely everything.
So that density could be a game changer for electric planes. What else?
Rapid rechargeability, but not by plugging in. The concept involves swapping out depleted sodium cartridges. Think minutes, not hours.
Swapping cartridges.
Huh.
That completely changes the operational side for electric trucks or planes, doesn't it?
It really could. No long waits at chargers. And there's this other really intriguing co-benefit mentioned.
Go on.
The byproduct of the reaction is sodium oxide. And apparently, this sodium oxide can absorb CO2 directly from the atmosphere.
Wait, so the battery could power a vehicle and help capture carbon?
That's the idea. Well, it's quite a combo if it works out.
So what's the timeline? Are we talking decades away?
The initial targets seem ambitious but phased. They mention powering large drones within the next year or so, then potentially enabling electric aircraft flights up to maybe 930 miles.
Yeah.
That covers a lot of regional routes.
Okay, that's definitely one to watch. Any other big battery news this week?
Yeah, a few other threads. CATL, one of the world's biggest battery makers, announced a breakthrough in lithium metal batteries.
Lithium metal.
Yeah.
That's different from lithium ion too, right? Higher density potential, but challenges with lifespan.
Exactly. CATL claims they've doubled the cycle life, how many times you can charge and discharge it while maintaining high energy density, around 500 weight-each kilograms. That's crucial for things like long-range EVs and potentially electric aircraft, too. Addresses a key weakness.
And solid-state batteries. Still the holy grail.
Progress continues there, too. Sources mention research focusing on something called space charge layers to improve performance.
Space charge layers.
Well,
Okay, what's the simple version?
Basically, think of it like carefully engineering the boundaries, the interfaces between the solid materials inside the battery, creating tiny electrical fields right at those interfaces to help the ions move more easily and quickly. It's very technical, but the goal is faster charging, better power delivery, more stability for solid state.
Got it. And it wasn't all high-power stuff either, right?
Yeah.
There were some biodegradable options.
Yeah, which shows the sheer breadth of innovation. Things like Flint's paper battery or ModePack, using lignin, the stuff that makes wood stiff, to make compostable mailers instead of plastic ones.
Lignin mailers.
Yeah,
Using a waste product from paper mills for packaging.
exactly. So innovations happening from, potentially electrifying planes right down to making everyday disposable items more sustainable.
And underpinning a lot of the renewable integration is grid storage, which is growing incredibly fast.
Yeah, the U.S. saw record deployment in the first quarter of 2025, 1.6 gigawatts of new battery capacity added. It's not just about storing solar and wind anymore either. These batteries are providing crucial grid services, stability, frequency regulation. They're becoming sophisticated grid assets.
So you can really see the innovation engine firing on all cylinders across solar and storage.
Yeah.
So yeah, it's a lot to keep up with. But that's why we do these deep dives. If you're finding this useful, if you want to stay on top of all these fast-moving developments in clean energy.
You know the drill. It really helps us keep bringing you this content.
Please do. Host speaker and expert speaker. Like, subscribe, and turn on notifications. Seriously, it makes a difference, and we genuinely want to know what resonates with you.
Yeah, what stood out? Host speaker and expert speaker. Comment below. Which clean tech update impressed you most?
All right. Let's shift now to another area that's seeing both significant investment and, frankly, some really intense debate. Carbon capture and geoengineering.
Yeah, carbon capture, utilization, and storage CCUS. Investment definitely keeps flowing. We saw the UK allocate another $9.4 billion for projects through 2029, supporting existing industrial capture hubs and developing new ones.
And private companies are raising money, too.
Yep, like Air Capture getting $50 million for their modular direct air capture or DSE units. Those are the ones designed to pull CO2 straight from the ambient air.
So clear policy support in some places, private sector interest, viewing it as a necessary tool, presumably. But the sources also highlighted some very critical academic perspectives this week.
Oh, definitely. A Stanford study got a lot of coverage. Its main argument was pretty stark, relying heavily on CCUS and to see would be, in their analysis, 9 to 12 times more expensive in overall societal costs compared to just going all in on 100% renewables by 2050.
9 to 12 times. That's a massive difference. What's the logic there? Societal costs include what?
Yep. It's about the total system cost. They argue CCUS basically adds big energy penalties and huge infrastructure costs, like all those pipelines needed to move the CO2 onto existing fossil fuel systems. And it doesn't solve other problems like air pollution from burning the fuel in the first place.
Whereas the renewables transition, while needing upfront investment, eventually lowers fuel costs and avoids those other pollutants.
That's the core of their arguments. So the Stanford researchers basically suggest policymakers should maybe rethink promoting CCUS so heavily, arguing it could divert resources and focus away from what they see as more effective, cleaner solutions like direct electrification.
So a real debate about the best path forward. And beyond the cost debate, actually building the CCUS infrastructure is hitting roadblocks.
Absolutely, especially the pipelines needed to transport the captured CO2. We saw examples from the U.S. just this week. Iowa's governor vetoed a bill that would have put stricter rules on a CO2 pipeline project. Meanwhile, South Dakota just flat out banned using eminent domain for CO2 pipelines.
So significant local opposition and regulatory fights over land use and safety concerns adds another layer of difficulty.
For sure. It's not just about whether the tech works or the economics add up. Public acceptance and infrastructure build-out are huge hurdles.
But we are still seeing specific CCUS projects pushing forward. trying different things.
Yeah, the sources mention some interesting examples showing the variety, like capturing CO2 from the fermentation process at a winery in Spain that's a concentrated source, easier to capture.
Okay.
Or a mobile test plant in Sweden using new solvents that require less energy for the capture process. And that pilot plant in Hawaii, Captura, trying direct ocean capture, pulling CO2 dissolved in seawater.
Direct ocean capture, actually. So innovation continues, but that fundamental debate about the overall role and cost effectiveness versus renewables just seems to be getting louder.
It really does. It's a central tension. And somewhat related, what about the even more controversial area of geoengineering, specifically solar radiation modification, SRM?
Yeah, the idea of, say, spraying aerosols into the stratosphere to reflect sunlight and cool the planet. Research on the physical impacts continues, but the focus this week seemed much more on the governance and ethics.
That's definitely where the conversation is shifting hard. Studies are highlighting huge uncertainties. Like, how would dimming the sun affect rainfall patterns? It might cool things overall, but could it cause droughts in one region while maybe helping another? We just don't know for sure.
So the potential for unintended consequences and for those consequences to be distributed unevenly around the world.
Exactly. And that raises deep concerns about equity. Who gets to decide? What if it helps richer nations but worsens conditions, say drought, in poorer nations that are already suffering most from climate change? It could actually exacerbate climate injustice.
That's a terrifying prospect, the
Yeah.
potential for unequal outcomes, creating winners and losers on a global scale.
Right. And these concerns about risk perception, public trust, climate justice, who controls the planetary thermostat are moving from academic debate to, well, real-world policy questions.
Like Florida, moving to actually outlaw geoengineering tests
Yeah.
in its airspace.
That's a significant signal, isn't it? Even at a state level, lawmakers are getting nervous about the potential downsides and the sheer complexity of managing something like this globally. It shows a growing sense of caution.
Okay, let's move to something perhaps more tangible, more ground level, but equally transformative. The circular economy and sustainable materials. Seems like we're moving past just talking about it.
Definitely. The sources paint a picture of a real shift from concepts and pilots towards concrete regulations and industry adoption, especially in Europe.
The EU seems to be leading the charge here. EU Green Week signaled a move to implementation.
Yeah, less talk, more action. And the upcoming EU Circular Economy Act looks set to really codify this, mandating things like minimum recycled content in products,
Setting actual durability standards so things last longer.
and rolling out digital product passports to track materials and components through the supply chain. These are becoming legal requirements for selling goods in the EU.
And specific rules are already kicking in, like for textiles starting next year.
Yes, January 2025 for textiles, including extended producer responsibility, EPR schemes. Companies will have to pay based on how easy their clothes are to recycle eco-modulated fees, and a ban on destroying unsold goods. That's huge for the fashion industry.
And because the EU market is so large, these rules basically become global standards, right?
Pretty much. If you want to sell in Europe, you'll likely need to meet these requirements. It forces companies everywhere to rethink design, materials, end-of-life management.
So that's the top-down policy push.
Yeah.
Are we seeing industry responding with innovation?
Yes, definitely. The packaging sector is really active. Sunoco rolled out that fully recyclable all-paper can in North America, certified for curbside recycling, which is a big deal for containers usually made of mixed materials.
Right, getting rid of those plastic or metal layers.
And we mentioned Modepac's lignin mailers turning wood byproduct into compostable packaging, tangible examples of companies finding alternatives.
Mass timber in construction also got highlighted again.
Yeah, a study suggesting that widespread adoption could make a serious dent in global CO2 emissions. Maybe 7 to 25% reduction by 2100, which is a huge range, but significant.
How does that work again?
Two ways, really. First, the wood itself sequesters carbon, locking it away in the building structure for decades. Second, increased demand for sustainable timber could incentivize more reforestation and better forest management globally. Plus, it avoids emissions from making traditional concrete and steel, which are very energy intensive.
So, a potential double win. Carbon storage and avoiding emissions.
That's the argument. It's presented as a key sustainable building solution.
Okay, so stepping back and looking across everything we've discussed, fusion, thorium, SMRs, solar, batteries, CCUS debates, geoengineering ethics, circular economy rules, new materials. What are the big overarching trends shaping this whole energy transition right now?
Well, several things really stand out from the sources this week. First, that stark policy divergence globally. You've got proactive, comprehensive policies pushing ahead fast in the EU, UK, China.
Contrasting sharply with, well, a lot more uncertainty and even regulatory rollback talk at the U.S. federal level.
Exactly. Which leads to the second trend. This growing tension within the U.S. federal uncertainty versus the real, tangible economic activity happening at the state and business level, like those Arizona leaders warning about $58 billion in investments and nearly 70,000 jobs being at risk if Inflation Reduction Act incentives get cut.
It really shows the transition is already an economic engine, creating jobs and investment locally, regardless of the federal noise.
Yeah. Third trend. Energy security. As we said up front, it's increasingly a major driver, especially in Europe, sometimes aligned with climate goals, sometimes maybe even overrating them slightly, prioritizing domestic control and resilient supply chains.
And a newer factor, but potentially huge, the energy demand from AI and data centers.
That's exploding onto the scene as a major force. These facilities need immense amounts of reliable power, 247, and increasingly, their corporate owners want that power to be clean. This could massively accelerate demand for renewables, grid storage, maybe even SMRs for dedicated, clean, reliable baseload.
We're also seeing, it seems, a more mature understanding of sustainability itself, going beyond just emissions.
I think so. More focus on the full life cycle, discussions about decommissioning old solar farms, the mining impacts and supply chains for EV battery materials, even the energy footprint of training these huge AI models. It's becoming a more holistic, cradle-to-grave perspective.
And finally, the money side. Sustainable finance had some mixed signals.
Yeah, interesting point. While overall clean energy investment is still projected to outpace fossil fuels globally, the market for specific green bonds or sustainable debt seems to be contracting a bit right now. That could potentially create challenges for financing some of the really large infrastructure projects the transition needs. Something to watch.
Wow, okay. So it has been an absolutely packed week. Groundbreaking tech like the fusion steps, China's thorium refueling, those potentially revolutionary batteries from MIT and CATL, real progress in sustainable materials.
But alongside that, these really intense debates about the cost and role of carbon capture, the profound ethical minefield of geoengineering.
All playing out against this backdrop of diverging global policies, new energy demands from AI, and shifting financial currents.
This deep dive really hammered home just how complex this transition is. It's not one simple path. It's this dynamic mix of science, policy, money, social factors, ethics, everything interacting.
It definitely leaves us with a lot to chew on. Thinking about all these forces, the incredible tech leaps, the policy headwinds and tailwinds, the investment flows, the crucial social and ethical questions. What factor do you, our listeners, think will ultimately be the biggest single accelerator or maybe the biggest break on the global clean energy transition over the next, say, 5 years?
That really is the crucial question, isn't it? What will tip the scales?
Something to ponder. Thank you for joining us for this deep dive on Green Code Hot Core here on Tomorrow Unveiled. We'll see you next time as we continue to explore the future unveiled.